So this matrix is essentially what our end goal is going to be to help us solve a system of equations. So on the next page, you'll see about using row operations to get a matrix into this form. But first, just how does this form help us? So we have our augmented matrix. Essentially, these are x coefficients, our y coefficients, and our z coefficients. And that dotted line is like our equal sign. So from this augmented matrix, go back to a system of equations. This says x plus 2y minus 5z equals negative 10. Y plus 3z equals 9. And z equals 4. So notice, in this form where we have all of these zeros in the corner, and then our diagonal ones, when we write that as a system, we have a variable solved for right away. Now, on top of that, we can easily just go up one equation. This process is called back substitution because you're working backwards. We go up one equation. We have y plus 3 times 4 equals 9. So now this is a very simple equation to solve. 3 times 4 is 12. Subtract 12 from both sides. And we get y equals negative 3. And now notice we work back one more time into the very first equation to solve for x. So we have x plus 2 times negative 3 minus 5 times 4 is negative 10. 2 times negative 3 is negative 6. Minus 20 equals negative 10. Add 20 to both sides, and we get x equals 16. So now that the matrix was in that form, we could easily solve, and our answer is 16, negative 3, 4. So that process is called back substitution. So now the next slide is going to put the idea from the first slide together, the process in the middle, which is called Gaussian elimination, and then you'll get here and use the back substitution to finish solving your matrix.